The overall goal of this protocol is to create a large volume tissue illuminator that is well suited to optogenetic manipulations in non-human primates.
This method can help answer key questions in the field of neuroscience, such as how do populations of neurons in the different brain regions contribute to behavior, and how can temporally specific neuronal firing patterns in one region impact another region. The main advantage of this technique is that it uses light, and thus allows optogenetic manipulation of large, behaviorally relevant brain volumes with minimal tissue damage.
The implications of this technique extend toward translational medicine because of the similarities between the human and non-human primate brains.
Generally, individuals new to this method will struggle because it takes some practice to apply the proper amount of pressure when pulling these fibers.
To begin this procedure, use a pair of sharp shears to cut a section of 250 micrometer diameter plastic optical fiber that is at least 10 centimeters longer than the desired total illuminator length. Next, remove a 15 to 20 centimeter of polyethylene jacket from one end of the plastic optical fiber using a 22 gauge wire stripper. Then, secure the distalmost 3 to 5 centimeters of the stripped end of the fiber in a table vise clamp. Hold the jacketed end of the fiber taut in one hand with a constant steady pull. The fiber should be parallel to the floor, pulled away from the vise. Maintain this constant tension on the fiber throughout heating and cooling so that the fiber remains straight and taut as it thins. Using the lowest setting of a dual temperature heat gun, heat the stripped section of the fiber until it is thinned to a diameter of 60 to 100.